Welcome, I'm the Mad Farmer. In this video, we shall discuss method of differentiation. Differentiation. Now, in differential calculus, there are two methods we can use to find the differential coefficient. Yes, there are two methods we can use to solve or to differentiate a function. The first method is what we call first principle method. Then the second one is what we call direct method. Now, we have an example on the board. Differentiate y equals to x squared. This is a function. A function have two variables, dependent and independent variable. Now, the question is, we should differentiate this function. Now, we want to use a first principle method to differentiate this. Now, if you want to use first principle method, the first principle said you follow this step I want to follow now. The first thing, increase y by delta y, and also x by delta x, and add them to their both sides. Now, what I mean by that is increase y by delta y. This is delta y. Also increase x by delta x and add them to their respective sides. So I've increased y by delta y and added to the left hand side where y is. Then I've increased the x by delta x and add it to the right hand side where x is. And x here is having a power, raised to the power of 2. That's why I put it in brackets. Had it been raised to the power of 3, we have it. Had it been there's no power, we don't have to put a bracket. So the next step, make delta y the subject of the formula. Make delta y the subject. That means we have to move this y to this side, making it subject. Delta y is equals to x plus, you know what this thing means is two brackets, so we have to put the two brackets. As we are making delta y the subject, we are moving y to this side. That means we have y. Make delta y, that is second step, make delta y the subject. Now, the last step, replace the initial value of y. Replace the initial value of y in the question. Replace the initial value of y. What is the initial value of y? Look at it. The initial value of y, we should replace it here or substitute it here. So what we are going to have is delta y is equals to, okay, let's expand straight as we are replacing it. This times this is x squared. X times delta x is x delta x. Then delta x times delta x times x is x delta x. Then now delta x times delta x, they are the same. Delta x plus delta x squared minus. We are replacing the initial value of y here. That means initial value of y here is x raised to the power of 2. We will replace it here. So now, at this juncture, we have to collect like terms, those ones that resemble themselves. We have x squared here, x raised to the power of 2 here, and we have it here, negative of it. So now, this and this look alike. That means this plus this, we're going to have 2 of it, 2x delta x, then plus delta x squared. So now, if you watch here now, that x squared minus x squared will be what? 0. Goes out. So leaving us with delta y is equals to, what remaining here is 2x delta x plus delta x raised to the power of 2. What remaining here? We have cancelled this out. This minus this, 0. Remaining this and this. Now, the next step said divide both sides of the equation. Divide both sides of the equation by delta x. Divide both sides of the equation by delta x. Divide here by delta x. This side by delta x. You come to this side. Divide it by delta x. Can you see it here? If you watch here, yes, I'll divide both sides of the equation by delta x. So what we have here is delta y all over delta x is equals to. So now, this delta x here is dividing all the delta x here, all the terms here. That means this will cancel out this, and this will also cancel one of this, leaving us what's remaining here is 2x. What's remaining here? One has cancelled one out, remaining what? 1 here, delta x. So now, the next step, take the limit. Take the limit of delta x in the right hand side. Take the limit of delta x in the right hand side. What does it mean? Limit. Whenever you see delta x in the right hand side, you put what? 0. Whenever you see delta x in the right hand side, you put 0. And we are going to change here to dy dx. This is same thing as dy. Change this delta y all over delta x, same thing as dy dx. Derivative of y with respect to derivative of x. So now, whenever we see delta x in this right hand side, we'll put 0. So there's no delta x in this term. There's delta x here, which is now 0. So finally, dy dx is equals to 2x plus 0 will give us 2x. This is the result we get when we differentiate this function. Thank you for watching. Do well to follow my YouTube Mad Farmer, Instagram Mad Farmer, Facebook Mad Farmer, TikTok Mad Farmer. In our next class, we are going to use a direct method to solve this problem. Thank you for watching. Don't forget that this video is proudly powered by USA Tutorial Center. See you in our next class. Bye bye.